Our next presenter is Tina Tsou, who is the head of IPv6 research with Huawei, and pretty excited. As most of you are probably aware, there's a lot going on in the manufacturer space. So Tina, why don't you come up and we'll go ahead and get started with the next presentation. So you can either use this or use the keyboard. All right, thank you.
Hello, everyone. This is Tina Tsou, the IPv6 research head at Huawei. Glad to be here, and thank you for the invitation from gogoNET. So today I'm going to talk about how we overcome the challenges of deploying IPv6 in the live enterprise network in the real live environment. So a lot of people say it's only IP, right? So how about we making the case, define how to make the how to define success, and then test 360, and planning the transition in the real enterprise networks. So we have a lot of deployment details like UCC, it's unified communication and collaboration, and all the different applications like emails, file transfer, et cetera, and the different networks and the platforms. I was involved in the different SDOs, but today I become real IT customer. I'm wearing a new hat. So go to the session 1. I'm going to talk today, the best practice and overview. Again, it's only IP, should be easy, no? But what about the security policy and devices? The company I work has the very different environment. And the security policy, like at work, you have the proxy server to go out to view the different websites. And the security InfoSec people want to audit some certain levels of the interaction. That the main reason is to prevent some code being distributed outside the company by no reason, no legal reason. And we have the different operating system, like the different hypervisors, and no mention the different servers like Windows X, Linux, all these different version servers, and the PCs with Windows, Apple, or HP, IBM, all these different PCs, and the smart devices from iPhone, iPad, Android, all the different devices. And the network platforms, we have many BUs, have the different platforms from the access, aggregation, core, transport to data centers. Everything is different. The key point is the service and applications, which is visible to our end users. Like they want to have VPN to connect people globally around the world, like from China, Asia Pacific, Europe, Africa to North America. And the how to do some application optimization. We have the different upgrade of the different software even every day, because we use the IT produced applications every day. And UCC, I mentioned, it's somehow like Skyping. You can use for voice over IP and video and conference calls, instant messaging, emails, and directorate of all the telephone books of the employees. And the private and public cloud applications, and some of our terminals are cloud client. And you have questions, or is it too late? Okay. And regarding the DNS, DHCP, all the printing stuff, and we use the Windows domain system for our printers. And the last thing is the monitoring and troubleshooting tools. If our IT guys do not know how to troubleshoot, if there is a problem happened for the IPv6 network, we wouldn't call it the real live environment for IPv6. Because in the beginning, all our IT guys just call me 10 times a day, Tina count SOS. I think this is not the right thing, so we start doing some education and get them really involved, and they can troubleshoot if there is a problem happen. Making the case, you can see in the circle, this is IT, and there are 4 pieces, like business executives, security operations, application and server operations, and the business function leaders. We have to work with the 360 environment of different people from different BU, different functions in the company. For example, for the business executives, so we have the so-called BYOD, bring your own devices to the company. You know, the iPhone and Windows 7, it's already supporting IPv6. If the users wish, they can just build up a peer-to-peer IPv6 network without getting into the company networks. So IPv6 will help us increase the IT flexibility for the new applications and communications. That's why we embrace the BYOD. And for the OPEX, it means more, we hope we keep the same thing, just the same OPEX. We just added new skills to our IT operation people. But the CapEx could be raised. But we hope it could be minimal. So then we try to reuse our existing devices and networks, just do the software update and the software upgrade, not just change all the devices immediately. It makes a lot of money. For the security operations, our security officer's name is Sunny New, and well, every time she saw me, she's not Sunny anymore. She's just, hi, Dina, you're making problem with me. Then eventually we are getting there, making her comfortable. She still can do all his, or her audit and all the InfoSec check with the new OS supporting IPv6. I'm telling her, if she doesn't embrace it, how can she and her team, as this InfoSec, information security team, will protect the business? There's no way. So that's why we get them involved very much. This is actually the key for our success. And the application and server operations, many applications and tools already support IPv6, and I see many of the companies in today's meeting already provide very good tools. And it results in a minor change to the existing environment and all the processes. Okay, final point is the business function leaders. How this will be non-intrusive to their users and business goals, but enable to their business, as I mentioned, the BYOD case. So we have to convince all these leaders it's different with the minimum cost. Then people might ask, how do we define the success? So first, we have to guarantee the business impact definition. First, when we talk to the different BU leaders, the first question will ask, will it impact my business? And then the second question will be, what kind of new benefit will it bring to me? So we have to guarantee there's no business impact to the current business. And then what's the scope of deployment? So in the beginning, we were very ambitious. We want to change the whole 4 or 5 buildings into IPv6. But we found out this is impossible. And then we talked about whether the branches, campus, or maybe from the data center. Finally, we figure out we will take is Chinese saying 一步一步. Translated into Chinese is step by step. Sometimes you take the baby steps, and we start from 1 room, 1 floor, 2 floors in this layered phased deployment. And we prove when the IPv6 work in small environment, we think small, but we do larger. We go larger. So is it at the edge or in the core? We actually took the core to edge, the hub and scope mode. So for the timeline for cutover, We do have a very good planning, but actually the procedure actually adjusted, and our planning always is updated. Because I remember first time I contacted Comcast, there was last year Christmas. And then even the Comcast working and talk to us, it takes some quite of time. And, and then we roll out the small room and one layer and bigger room. It all takes time. So our timeline is actually adjustable. For the cutover day, we defined a very clear, whenever we have all the application tested, and then we can move from white zone to green zone. White zone means it's disconnected from the company live production network. Green zone means we are connected with the company live environment. I will talk about, we have the different zones. Okay, so then we talk, a lot of business leaders is very concerned about. So we have many distributed applications. What's the delay number, and how are you gonna impact our performance? For example, before we can run the 100 or even more users for the access, the VPN tour at the same time for one building or whatever. But with this new IPv6, can we still run the same number of people at the same time? These kind of things. And it includes applications and networks. So then what's the design, the successful outcome? Then what's the exit criteria? So we also have very detailed document for all the criteria. We have the signature from the BU leader, IT leader, and the InfoSec leader. Then when we really do it, it's just test. First, we set up lab that mimics your target environment, but not at scale. So we have all the applications, DC, instance messenger, and emails, web browsing, file transfer between the different, actually we have the red zone, yellow zone, green zone, and white zone. White zone is the lowest one. And then we need to perform an inventory of applications, platforms, devices. I just talked about this. We work with all the employees to create a user story and the use case for the target environment. For example, our most active team is from our enterprise BG team. This team is very helpful. They have the enterprise infrastructure sub-team and the UCC team and the solution team and education team. They work with us. They told us whether they need what kind of access from white zone to yellow zone, and what kind of applications we have to make sure it works when we translate to IPv6. I said test. All the devices, applications, and permutations. Finally, it involves the security and other operations team. Early and often, even better if they are part of the testing team. In the beginning, the InfoSec people actually was reluctant to talk to us, and then we get all the IT guys are standing on our side. Then the IT guys strongly persuade the InfoSec people, guarantee we won't impact the company corporate InfoSec policy. And we do one by one. We open the document. We have a document. For example, green zone is our normal live production for the normal employee working environment. There is like 10 policies. We open the policy one by one and show the lead of InfoSec why our current IT IPv6 solution design will not impact, will not be against of the corporate policy. Finally, planning the transition. Also, as a vendor, we talk to all the customers. The customers from enterprise, from the telcos, provider service, they always mention all of these transitions. Now we really feel their need, feel how they feel. So first, we create the scope of the work, include the environment, platform, application, users, etc., etc. And the important part is get training for all impacted personnel for support of V6 and new systems put in place to support environment. All of us here, we understand IPv6 enough, but I was surprised to know, actually it was in March or in the beginning of this year. So Comcast gave us actually the /48 global routable address, and then our IT engineer, the normal maybe bottom level guy, he asked, why it's /48? I think the maximum will be /32 because his mindset is still IPv4. So you will see all of this. Even when we communicate with Comcast engineer, they say, oh, I'm so excited. This is my first time to get involved in real IPv6 provisioning. His whole life is all IPv4. So that's quite interesting. So we have a lot of educational thing to do for this. Then you need to inventory all the impacted devices and configurations, include the wiring plant, and like heating, violation, and AC, etc., etc. For example, we have to dig a cable from our building B to building C and building E. It's quite, how to say the distance? It's about 2 minutes walking to building C, and then for me, I walk slow. It's 6 minutes or 7 minutes to walk from building C to building E. So first time, the construction team even dig up one of the cable, and then we have no internet for 8 hours. And head of our organization was impacted. I got big complaints. So if your enterprise plan to do that, so be prepared to such kind of non-IPv6 related issue may happen just all of a sudden. You don't know how to fix it. And we have to work with Comcast engineers until 4 a.m. in the morning. It's a miserable story. Anyway, so So we did create a clear documentation and points of contact for transition activities. We do have the IT contact and the IPv6 project contact, like me, be called Midnight. And all OPS teams must be deeply involved, include the security, InfoSec, information security, the APP guys, server guys, and network guys. Because in our IT team, the server guys are different group of people. They just subdivide into different subgroups. Then socialize the scope of the work and get buy-in, means the InfoSec guys feel comfortable. There's nothing against the policy of the company, and the signature of the cutover days and times. We do have many signatures, but we actually always got a little bit delay because of something just happened on the road. And then we go live. So here is the IPv6 production office networks. With the mind, we want to try IPv6 only, but we got /48 from Comcast. First, we have to acquire the IPv6 address space and then the internet service and access. So our design goal and principle include this will enable all the employees to have IPv6 access and explore the practical IPv6 deployment and all the transition options, what we heard from the customers all the time. To enable employees to innovate and collaborate with external partners. Like we use this IPv6 lab environment to work with Vodafone, far from Italy. They can remotely access, and China Telecom remotely access from China. and people from Telefonica in Spain. They all reuse this platform to do some innovation collaboration, and then we just make the best practice improvement based on IETF standards. Then we feedback to IETF to see whether we can have some optimization on the standards. And finally, our product teams to test the new implementations. Like our Dallas team, this IP solution testing team there, we allocate them some segment of IPv6 address. They can do all the testing real, not just like create some fake IPv6 address. Okay, so then we go to the session 2, the network architecture, the IPv6 Lab Networks. As I said, first we have to go on the white zone. This white zone means it's disconnected from your daily work environment to test everything, to prove all the applications work. Then we can go to green zone. Here is our IPv6 network layout. You can see we get from Comcast and Comcast C router. So, thank you. So it's 10 minutes past or 10 minutes left? 10 more. Okay, I should be quick. Yeah, and you can see here we got this routable global IPv6 address. Then we distributed this address space to the topology and functional different teams involved into this, like our wireless team, wireline team, the carrier team, and enterprise team, and even the software team. So we gave them different IPv6 address. Okay, you go and play, and then report to us what applications, networks, platforms, and experience, and what kind of impact, what kind of thing you want us to change in the existing software version, etc. Here is the CGN and PCP layout. PCP is port control protocol. It's just because it's used for some firewall and net traversal use cases. I guess most of you might be familiar with this. Then we use the different P2P client and the web server, network coordination client. Actually, Vodafone use this for a lot of fun for testing and have their FTP server in their network, and somebody want to visit from outside, from external networks, then it works. So here we use IPv4 over IPv6 for this slide. But actually, it can work for either this slide, NAS44, 64, etc. And here is the Multicast Service 6 transition 64 case. For our eSpace, sometimes we have video conference. Then we need, for example, here in the lab network, we collaborate with CERNET. CERNET is Tsinghua University in Beijing. They have the big educational network. It's IPv6 only. But they provide a v4 content server, and then it goes into our v4 multicast content server, and we have some translation application adaptation function here to translate people 4 and 6 for multicast. And here is lightweight for over 6. Actually, this is requested by China Telecom mainly, also France Telecom, Deutsche Telekom. It's for the per subscriber stay 4 over 6 and no V4 and V6 address coupling. It means address sharing. Here is also we using Comcast Internet Services. We did this trial, and actually it's 7 operators, 8 vendors participating in the interrupt. And China Telecom kindly gave me this T-shirt. This is lightweight for over 6 T-shirt. Okay, so the most interesting part is the live production network. How do we do this? Phase 1 for the enterprise network transition. So we have to first check with the security and compliance, the multi-zone networks based on use, and the internet networks highly secure and regulated actually by corporate HQ. Our guys have to talk to HQ every night. We phone them to make sure we did not cross the red tape. Otherwise, we got problem. Our IT guys might get fired because of violate those red tape. So nothing goes on the network unless approved by the information security and IT. In this case, our existing infrastructure not ready, no v6 port. So our support is minimum to non-local resource. And then, okay. The strategy, the security and compliance, the solution of proof of concept implementation that does not break the rules. We have to utilize the existing network, no change in our IT infrastructure. Get the local region IT buy-in, this is a key. Here is a picture you can see we have deployed IPv6 Lab Network with dual NIC Linux host running 964 DNS64 services. So you can see we actually allocated the 2001 DBA 1 FFF //96 for the NET64 DNS services. So we use Red Hat Linux host here, running NET64 DNS64. It works very well. In this case, we are able to, you can see, actually, our web proxy server and our SharePoint server, this is the main service all the employees use every day and every minute. So we have to adjust it to this. You can see we use the NET64 gateway here under the IP. So it's 6, 4, 6, then internet, then 4, then internet. So with this, our host be able to ping and telnet access resources and browse and use web proxy. Our next step is to explore and incorporate additional v6 technology like DHCP v6. We have a trial recently supporting the meeting, IEEE meeting, is HOTI meeting sponsored by Huawei. So then I will just skip the eSpace UC signaling flows. We are running out of time, sorry about that. So it's about SIP, RTP, all of the signaling flows, which we plan to run next month in our campus to facilitate our UCC. Additional use cases, based on all our IPv6 experience, we permanently launch IPv6 on Huawei website, for Huawei website. And here is what I mentioned, IEEE meeting. Here is a small video for your entertainment. Oh, it doesn't work for PDF version, right? Bruce? It's PowerPoint? Okay. Yeah, I think this is... I don't know why. It works yesterday. Okay. It's a pity. All right. So this is our infrastructure for how to run this IPv6 Wi-Fi, and we sponsor actually 200 people. It's more than 200 participants for IEEE meeting there. This video is about participants. One from France Telecom, the other from Siena. They tell their user experience. Additional reference you can find on Huawei website. Thank you. I think we just have 1 or 2 minutes. Still questions or? Okay, thank you.